talking about motion and forces. Yeah, I'm gonna shoot a video about it. Oh, hey, gotta go. Just talking on my cell phone. Talking about motion. Motion can be a pretty cool thing. But how do you know if you're in motion or not? Well, we use something called a frame of reference. Kind of like the box I'm standing in right now. A frame of reference is an object or a point from which we determine if something is moving. There's many ways to think about this. For instance, it could be a starting point on a map, such as a house. You start at your house when you come to school every day. Compared to your house, you moved. Your house is what we call a frame of reference or reference point. An individual's frame of reference could also be your current location or your position. For example, let's imagine that you're in this nice big box with me. Compared to you, me, the box, we're not moving. We're just kind of hanging out. But what if you are standing outside the box? Then you might realize that that box is moving. Reference points can be tricky sometimes. Have you ever been sitting in a parked car next to a large bus or a large semi-truck? The bus moves or the truck moves forward, you feel like you're going backwards. Because compared to the truck, you are going backwards. Compared to everything else outside of your vehicle though, you're not, you're standing still. So motion is always dependent upon a reference point. Now there's three things that we talk about when we're talking about motion: position, distance, and speed. When we talk about an object's position, we can describe it relative to a reference point. That means if we know where one thing is, we can tell where something else is. If you know where the box is, you know that I'm inside the box. Here's another example. Take a look at this bookshelf. The race car, we say, is above the baseball. The bear is below the clown. The boat is inside the bookshelf. We can also describe position using words like left and right. In this picture, the house is to the left of the baseball. The bear is to the right of the pink rabbit. I am to the left of Drake. Nice moves, Drake. When an object moves, it changes its position. An object can be above, below, in front, behind, to the right, or to the left of its original position. When you put all those together, it kind of looks something like this. When an object is not moving though, it's at rest. Another important word you need to know is distance. Distance is the length between two positions or two locations. We measure distance in meters, kilometers if we're talking longer distance, or centimeters or millimeters if we're talking very small distances. Now, how do we calculate the speed of an object? Well, the speed of an object is a measurement of how the position is changing over time. It shows how fast the object is moving. Like position, speed is also relative, meaning it has to be defined by comparing it to something else. For example, if a car's speedometer says 60 miles an hour, the car is traveling at 60 miles per hour relative to the road or compared to the road. If a car is moving 60 miles per hour next to another car that's also moving 60 miles per hour, then there is no speed compared to the other car. Objects can move at different speeds, and in order to figure out the speed, you have to measure how long it takes for the object to travel a certain distance. Objects can also move in different directions. We use that term velocity to describe both the speed and direction in which an object is moving. If two objects are moving for the same amount of time, the faster object is going to travel farther. In the same way, if two objects move at the same distance, the faster object is going to take less time. You can see that based on this graph here. One way to show how different objects travel is to make a graph of distance versus time. In the graph that you see here, object 2, which is in red, traveled farther than object 1, which is in blue, in 6 seconds. This means that object 2 traveled faster than object 1. Here's another example. Let's say I want to calculate my speed from the top of the steps to the bottom of the steps. First, I have to measure my distance from the starting point to my ending point. Then, I have to record the amount of time it takes for me to get down the steps. To calculate the speed, I divide the total distance I went divided by the total time it took, and that's my speed. If I wanted to describe my velocity, I would just add the direction I went. In your lab journal, make sure you have how forces can cause motion. Make sure you know what a reference point is. Make sure you know what distance is and how to calculate speed. Bring that with you, and I'll see you in class.